Hi, Jose.
Hey!
How are you?
I'm awesome! How are you?
Amazing. Do you want to know what I learned the other day?
Oh, what did you learn?
I learned about water and all of its properties.
Tell me about it.
Okay, so water can be called several ways. For example, you can call water as hydrogen oxide, hydrogen hydroxide, hydrogen monoxide, or hydric acid, and many other different names.
Whoa!
At the same time, water is a molecule that contains one molecule of oxygen and two molecules of hydrogen.
Really?
Yes, really. Do you want to learn more?
Yes! Yeah. I also heard that it's bonded by polar covalent bonds. Is that true?
Yes, it is indeed.
Wow!
Chemistry is so fun.
It is! Let's learn more about this!
Hey, Jose, did you also know that water has many physical properties as well?
Really?
Yes, it has. For example, it has a boiling point and a melting point. Its boiling point is of 100 degrees and its melting point is of 0 degrees Celsius. Isn't that interesting?
Very interesting. I also knew that the density varies depending on the temperature, but it is generalized as water vapor 100 degrees Celsius, liquid water 4 degrees Celsius, and ice minus 30 degrees Celsius.
How interesting!
Indeed!
Now let's talk about addition and cohesion, as well as many other physical properties that water has.
Tell me about it.
Let me show you right here. Come, follow me.
Okay.
Hey! Hey everyone, I'm Susano, and I am the teacher. And I'm Mexican, and I'm building a wall. Okay, so let's continue. So, Jose went away, he went home. We're going to talk about addition and cohesion. First, in addition, we can find that the water molecules are close with other molecules, not with the water molecules. That's the difference. And this is because water's polarity. And in cohesion, we can see that the water molecules stay together or stay close to the water molecules, to other water molecules. And this is because of the hydrogen bond. Yes, water has really high surface tension. This means that water is sticky and elastic and tends to clump together in drops rather than spread out in a thin film. Here. Water also has capillarity. This is produced by the addition and surface tension. It happens wherever water rises into a narrow tube against the force of gravity. Surface tension allows water to move through the roots of plants and through the tiny blood vessels in our bodies. Water needs specific heat to raise its temperature. Then is this important formula, which is 1 calorie divided by gram Celsius degrees equals joule divided by gram Celsius degrees. Look at that pretty lady right there. And it is important to say that it absorbs a lot of heat, water of course. And because of this, it is very used, for example, as a car coolant. This explains too why weather doesn't change suddenly. The specific heat is controlled by a person, but in heat of vaporization is controlled by the nature. This means that water can take a lot of heat without its temperature rising that much. And this plays a huge part in the climate because it means that oceans take a long time to warm up. Okay, so water has other properties. First, water is also called the universal solvent. Why? because it dissolves more substance than any other liquid. It as well dissolves ionic compounds and polar covalent compounds. Pure water, which you will not find in the ecosystem, has a pH of 7, which is neither acidic nor basic. It is important to say that pure water doesn't conduct electricity unless it is dissolved with other substances. Water is constantly replaced by the water cycle. Now, about 1.5 million kilometers, thank you, Juan. Al cubo, I think so. On Earth is the cantidad we have for water. Then, less than 1% of the water is available for consumption. This is really sad, my children. Water availability. Alright, so these are the percentages for the water availability. And as we can see, there's a small line right there in the blue part. That, my children, is the amount of water we have for drinking. That small line right there. The water cycle. It describes the continuous movement of water on, above, and below the surface of the earth. And today we have a special guest.
Hi.
Hi, Susana. How you doing? How you doing?
Hi, thank you.
She's a little pretty girl, right? We'll discuss this later. Okay, so first we're gonna start in the oceans. Here, water evaporates. Evaporation. It evaporates and goes into the air.
And then condensation happens, and clouds are formed. And then precipitation.
Shut up. I'll continue. Thanks. Precipitation happens, and in here, the water goes down. It rains, and thanks to the water, is that it goes back to the oceans. It's raining! Yeah! Now, ocean absorption of carbon dioxide. Here we have two problems. The first one is the ocean carbon storage. Here CO2 goes into the ocean and bubbles of CO2 are stored in the sand. Any animal species or fishy, like this one, poor little guy, that goes near it, they die. Or they have circulatory problems. Poor little guy. Well, we have another problem, and this is ocean acidification. CO2, as well as the other one, goes into the ocean. But here, it affects the calcium of the shells. And because of this, any species that are near it are affected as well, just like this one. But it as well affects, the calcium, and because of this, the shells are either weakened or destroyed. Serious problem.
Sources of pollution. The main sources of pollution are sewage, organic material, garbage as paper, plastic, metal, and glass. Another is industrial waste as lead, mercury, sulfur, and oil. Radioactive waste is another, and oil spills. As well, acid rain, global warming, and agriculture, like fertilizers. Main water pollutants and effects. Let's continue. Disease causing bacteria, virus and worms. Susano!
Yes, my dear?
Can you help me please?
Sure thing, coming!
Thank you!
Hey, how you doing? You need help?
Oui.
Oh, mon chéri! Est-ce que tu parles français?
Oui, monsieur.
Ça c'est bien, ça c'est bien. Let's continue. Then we have oxygen demanding bacteria. Yes.
Then we have water-soluble inorganics.
like acids, salts, and toxic metals,
Then nutrients as
nitrates and phosphates,
oil,
plastics,
pesticides,
radioactive compounds.
and heat.
Let's learn more about this!
So, how do we get the water that we drink? Haven't you asked yourself that question? That important question? Well, here we will explain you why or how. So we have water treatment, and it is divided in 3 treatments. The first one is a primary treatment. In here, there are 2 processes. The first one is called screens, which removes the big solids. And the second one is sedimentation, which removes the land and the soil. Well, after what was said, then we move on to the secondary treatment. In here, it is divided as well, just like the primary treatment, into 2 steps. The first one is activated sludge. In here, the different organisms degrade biological content from the organic material. Then we have the clarifier, which removes the sludge. Now we go to the tertiary treatment, which is the longest one. As you can see, we have 3 steps in here, but there are 2 more to come. First, we go to filtration. In here, the sand or activated carbon filters retain the suspended matter. And then we go to the nutrient removal, which is nitrogen and phosphorus, and they are removed. The disinfection, which reduces the amount of living organisms. And for this one, we have 3 methods that I will explain in later. And so, as we said before, there are some methods for disinfection. These are 3. First one is the chloride. This is the most common and cheap. It can generate chloro compounds that may be carcinogens. Then, second, we have the ozone, which is unstable and reactive. It oxidizes most of the organic compounds. And last but not least, we have the UV light. It damages the genetic structure of bacteria and virus so they cannot reproduce. And there are 2 more steps to come. So in total, for the tertiary treatment, we have 5 steps. The last ones are reverse osmosis. In this one, the salts and other impurities are removed. Then, finally, we have distillation, which removes other soluble inorganic liquids. This drawing right here represents the reverse osmosis, how water goes in, and in here, the salts and other impurities are removed, and then it goes out. And all these processes are for having just the water, the one that we clean our hands. I know, right? And you might ask, then what happens to the water that we drink? Well, for that, there are more processes to come. For example, here in Mexico it doesn't happen, but in United States you can drink the water. Why is that? Because aside from all these steps, there are more to come. And that's why they can drink the water. This way. But we can't. The water is really important for us and for everybody living in this planet. Here, I'll tell you 3 reasons. The 2/3 part of the Earth's surface is covered by water. The 75% of human body is water. As well, the water circulates through the land and transports important things like nutrients to plants and to animals, to anything that needs water. And as the pathologist Dr. F. Batman Welby said in his book, "Your body's mainly cries for water." He writes, "Since the water we drink provides for cell function and its volume requirements, the decrease in our daily water intakes affects the efficiency of cell activity. As a result, chronic dehydration causes symptoms that equal disease." Okay,
So finally, here we have some interesting facts. First is that every 90 seconds a child dies because of a diarrheal, well, I'm Mexican, I cannot pronounce well, okay? Diarrheal disease, which is caused by contaminated water and poor sanitation. Then, millions of people worldwide live without access to safe water. $260 billion annually is spent on the fight against inadequate water supply and sanitation. Water cycle only creates 1% unusable water for humans, just 1%. And finally, do you know that plants sweat just like humans? I mean, that's weird, right? But that's awesome.
Let's now talk about the chemical properties.
Oh my god, what is that about?
So, first of all, it reacts with metallic oxides to form hydroxides.
And what else?
Well, it also reacts with metals to form oxides plus gaseous hydrogen.
Oh my god, that's too much knowledge.
Yeah! It also reacts with anhydrates to form acids. Also, it bonds with salts to form hydrates. And lastly, in double displacement reactions, water is usually formed Wow!
That was an experience.
Oh yeah!
And thank you all for watching this video. Click on like if you like. Okay. Thank you so much for enjoying, and we hope that you like this video. We gave all into it, literally blood, sweat, everything. Teacher, we love you! I love you from the bottom of my heart. Love you, teacher Marilu. Love you. Love you. Love you.
Mana mana.
Mana, mana.
Mana mana. Suena, mamalona suena, retumba los bajos, tiembla toda la cajuela. El humo que vuela es de la María. Ando dando la vuelta para ver si te veía. De noche y de día, toda la semana, marihuana y marihuana se besan con muchas ganas. ¿Por qué serás tan mala? Pregunta marihuana. Si cuando estoy contigo me siento más inspirado.
Walking, party, girls fucking me. Skinny jeans, oh na 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 na. Hey, 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 hey. Okay, okay. Ah na 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 na. Do you wanna? Nasla, jump. Hit the corner, stop, eh. Don't stop, eh. Don't stop, eh. Okay, ¡Comi! Tampoco. ¿Qué pasa?
¿Qué tipo?
No te Ay. Ven, por eso es que luego no vengo a trabajar. Un hombre que se esfuerza muchísimo. Vamos, si no veo.
Ese es bueno. No, para que ni.
Ni nada. Vean mis ojitos verdes.